Good to know. I didn't know you would eat Brussels sprouts so well.
Well,
You missed all of that?
so what we're coming up with here, we're going to try and load a video.
I'm here.
Hey,
What?
I'm here.
You've
Oh,
got
there you are.
your monitor working.
I clicked both of them, but it must not have taken because I just went up there again and it was closed. So that's the reason. It's all my fault. Okay, go ahead.
Okay, so we're going to cover a little bit on meditation. We're going to go back and review the Big Bounce, which was not the Big Bang. And then Marjorie has some materials to go cover. And that will be what we cover tonight. Now I'm just waiting for this other, let's see, let me do this. I'm gonna go share screen so you'll see what I'm trying to get load. Here we go. Here it is. So now let's go down here a little bit. This is all on our religion tab here on the Aleph Talks website. Oops, here comes Cheryl.
Yay, Cheryl. Another Cheryl.
I'm here. I'm trying to get all my computers going. And Barbara's coming over, so I'm waiting for her, but
Oh,
my
okay.
Apple just died and it's rebooting, so I thought I'd come on my cell phone just to get going. I don't want to hold you up. So
Okay.
hello.
Hello, hello. How are you feeling today?
Feeling good. I went to yoga tonight, so I'm feeling quite good that I did that.
Good.
So almost back to normal.
Welcome back to normal. Or
Whatever normal is, right?
right.
yeah,
It can be a mixed thing. Anything normal.
let me know when you figure it out. Normal is-
Really?
How to do it.
All right, I
Yes.
gotta.
Especially how to do it.
Yep.
Well, I think it's nice when you find somebody with compatible insanity, because then you at least make each other feel normal. And I feel that with Mark, you know. I'll just say that. And now that that's been recorded for posterity.
I'm just trying to get this back to. No, computer restarted because of a problem. Well, let's ignore that and see what happens.
I think we kind of have a little tribe here. I hope we do.
Yeah,
Make each other feel normal.
yeah, I think so. I think that's a pretty. I think there's something normal about that. We keep doing this over and over again. That says a lot, I think. All right, now where's my?
It's been quite a while too.
Yeah, it has been.
I finally got to it. Here we go. This is
Yay.
our meditation video. I like this because I've personally felt
During my travels in India, I
nature.
met a man at an ashram. He was about 45, 50, a little older than everyone else. He tells me a story. He had retired and he was traveling on a motorcycle with his wife at the time. Coming behind them, a truck ran into them and it killed his wife. And he was badly injured, almost died. Told he wouldn't necessarily walk again, in a coma for a while. When he came out of it and found out what had happened, he naturally was devastated and heartbroken and physically broken. And he knew that his road ahead of rehabilitation and physically and psychologically was going to be hard. He had one friend who was a yoga teacher who said, "We're going to get you started on the path to recovery." So she came over and through yoga helped him be able to walk again. After he could walk and regained his ability to move around, he decided to head to India and explore some more yoga. And while he was there, he started to learn about meditation, Hinduism, and Buddhism. So he told me that, he never would have thought to ever go down this path. He would have probably laughed at anyone who goes to India to find themselves. I said, "Did you get what you were hoping for?" And he said, "Even though I lost my wife, I've never been happier, because it put me on this path." I remember joking with my friend in high school that when you think about not thinking, we noticed that the mind never stops thinking. And we noticed that you really can't think about not thinking. And that was a kind of a question that plagued me for a long time. There's a greater wisdom that comes when we're not clouded in thought, when we're not lost in thought, when we're addressing exactly what's happening and not some mentally constructed simulation of what's actually happening. We always see movies and they have this beginning and end, but any movie you see, something happened before it started. We just don't see it. So we fall for this illusion that things have this beginning and end. For a long time, physics believed that there was a beginning to the universe, and only now they're beginning to say there might have been something before that. We get attached to certain people and forms and things and situations. The truth is nothing less. The truth is things will always change. When I was an ad man in New York, I had a unique perspective of how marketing and advertising works and how it creates demand and how it influences people to want products they would never normally have wanted. And I was responsible for a lot of that. More money, more clothes, more luxury items, more cars, vacations, nicer home, nicer furniture. We all know this feeling of you want something, you get it, you feel this rush of dopamine, and then very soon after, you crash and you want something else. The Native Americans have one of the most beautiful concepts in the world. They have 10,000 different languages in all these tribes, and none of them have a word for ownership or possession. They don't understand the concept of how something can belong to one person. It's really a man-made legal definition. You can't truly own anything. What you really realize is that so much of what people get obsessed about and go crazy over is just not important, not necessary. Yeah, I suffer because I crave things that I don't have, and I have an aversion to things that I don't want. When you can just step back and see the big picture and know that good things will come, good things will go, bad things will come, bad things will go, then your happiness doesn't rely on any kind of external situation. That's the key to lasting happiness. A lot of people in our modern materialistic world think that success equals happiness. If they just get this position or this raise or this bonus, they'll be happy. But personal experience as well as scientific studies have shown that once people's basic needs are met, more money, more success, bigger titles do not make us happy. We almost fail to see the blessings we have, and we focus solely on what someone else has we don't have. One book I read was called Becoming Your Own Therapist by a high Buddhist Lama. And that's, to me, what I found that spirituality really is. When you realize that life is an illusion, that everything is one, that everything has meaning because we project meaning onto it, that you can kind of awaken from this roller coaster of life, step off, and just appreciate and the marvel at the engineering of the roller coaster or the complexities of life, instead of feeling so attached to it and consumed by it. We all have spiritual moments throughout our lives. That first moment you see a sunset or a flower, maybe a piece of art, and you just say, wow. And in that really true awe and wonder, that childlike wonder that schools usually beat out of us, that is the moment we're all fully present, fully alert, fully appreciative. And there's a real connection made between the experience and the experiencer. God and the universe are really interchangeable words. The universe loves us, God loves us. Have faith in the universe, have faith in God. It's all the same. I mean, if God is everywhere, then God is the universe. And you don't have to believe in God to believe in the universe. I am God, but so are you. So is everybody. So treat everyone like God, including yourself. And remember, even though you're God, you're no better than anyone else. A wise man once said, "The universe created itself to experience itself through us." Names are useful in that they help you know who someone's talking to, but they can also be a deception. Because the truth is, we're all just the same. We're all one. Who you are, who you think you are, the personality you've constructed and that other people have told you are, your name, your class, religion, whether it's a sexuality or a gender or nationality. This physical body is your house. You are the inhabitant. And the you I'm talking about is the life force energy, the conscious awareness, which there is no physical part of the brain or body that science has found that is responsible for consciousness. And when we focus on these labels and identify with our temporary experience, we mistake our deepest sense of self with some temporary experience. And we see people as labels instead of infinite beings of potential. And it allows for a dehumanizing of each other. If you were to look at human skin under an electron microscope, you would not be able to tell where the human being begins and ends. There is no fine barrier between the person and the universe. There is just a flow from one to the next. And the only reason we perceive separateness is because of the limitations of our senses. Human beings can only see 0.0001% of the spectrum of light. And we can only hear 0.0001% of the spectrum of sound. If we could see infrared, and if we could see ultraviolet and X-rays and energy, hear the whole spectrum of sounds, the universe would appear very differently. There would be no empty space. It would be so full, we would just see this sea of energy, and there would only be oneness. There is no separate you. No separateness. There's a deep interconnectedness. There's only oneness. There's a difference between loneliness and aloneness. Loneliness is when being alone causes suffering. But aloneness is ultimately recognizing others as yourself. When you realize that you are one with everything. All suffering exists in the mind. No matter what happens to you, no matter how terrible, there can be peace. You are not your trauma. You are not your circumstances. You are that eternal, unchanging light of consciousness. Your true nature cannot be hurt. Your body can be hurt, your property can be lost, but nothing can touch the true you. Space, silence, and our pure conscious awareness are similar in that nothing can alter those states. You can never freeze space or burn space or alter space in any way. It's eternal and unchanging. this is the nature of our true selves. The realization comes that it's not your life. You can't possess something you are. You are life. All the knowledge and wisdom is in each and every one of us. You don't have to read any book or belong to any religion. This is a universal and available to everyone way of living. Never forget that every moment is a miracle. You know, that's the goal of spirituality, is to never forget that. Death is the beginning of the last great adventure and exploration of humanity. It's every person gets to go explore this thing that no living person knows about. Death in of itself is a beautiful process. It's like being born. Death is the great equalizer. No matter how rich or how poor, we're all going in that same direction. Everybody lives on through life living on. We're all the same life force energy. And that'll go on forever. Life will go on experiencing the universe as the universe intended. We've all been everybody, and we'll all be everybody. It's about enjoying the good times while they're here and knowing they won't last. And when the bad times come, we know they won't last either.
Okay. So there we have an intro. And let me get out of this. And Bruce had some thought-provoking words that I thought were worth sharing with everybody. So I didn't tell Bruce what I was going to show at the start, but hopefully it'll tie in.
Okay.
Go ahead, Bruce.
Oh, you want me to?
Yeah, just you want to read what you
Oh, yeah. It's a good idea. See if I-
You're on, Bruce.
Huh?
You're on.
you're on.
Yeah, okay. I'm just getting it together, okay?
No.
Okay. Realization mind comes from being in union with your own deeper mind that you have had forever already. It sees reality as it is and is not separate from the love and compassion that you have had forever. Okay, what was the next thing? The problem is believing in a self. The self makes you feel separate. You think there is other. Other does not exist. That's basically the fundamental understanding in Buddhism.
Very nice. By the way, Cheryl, did Barbara make it? You're muted. Okay, we lost Cheryl.
We're here. We just don't, the camera doesn't work again. We don't know why. It just doesn't work.
Hello, everyone.
But Barbara's here.
Nice
Hi,
to-
Hi.
Barbara. Good to hear your voice too.
Thank you.
And that was great that the self is the separation. I think that's just so ironic.
I like it.
Yeah. It's very hard to find, but when you find it, it's very obvious. That's what it's like. Realization mind is vividly clear and full of clarity and certainty and all kinds of nice things. But it sees through all that sort of thing instantly. And it's a very nice place to be.
Hmm.
Yeah,
Yeah,
very well said.
yeah, I thought it was pretty neat.
Thank you, Bruce. Very nice.
What?
So thank you, Bruce. Very
Thank
nice.
you. Thank
Oh,
you.
yeah, sure.
I wanted to just inject that I found it very interesting hearing that there are no Indian words for the concept of ownership. This is going back a long time to college days. I took that trip to Mesa Verde in Colorado and spoke to one of the ranger types, whatever there, who shared a lot about the cliff dwellings and how they all lived there. And they expressed that concept a little differently with an example that that if conversationally there were 100 acres on the top of the mesa that needed to be farmed or could be farmed, and there were 10 residents living in the cliffs below. If you divided it up, that would be 10 acres per person to work and farm that land. And if half of those people somehow perished, in our culture, the remaining people would take over that land because, hey, it was there, and they would now share it and have twice as much land. But their concept was that they only used or they had what they needed, not what was there. Just because it was there didn't mean it was theirs. If they needed it for their sustenance, it was theirs to use temporarily. But that kind of worked into the concept of lack of ownership. I always thought it was a very beautiful way to conceptualize this kind of a collective or community quote ownership of what they had, that they really didn't all own everything. They were temporarily using what they needed.
Hmm.
Steve, the Hawaiians have the same concept, to the best of my knowledge. They don't have a word for ownership either.
I think that's really nice.
Yeah, Stephen, if you ever look at satellite maps, you'll see that there's a road that is straight going from Mesa Verde to Chaco in New Mexico. And there's other roads that go in and out of Chaco. One of them goes over to Canyon de Chelly in northeastern Arizona. So they built all these roads and all of the cliff dwellings. Chaco has mostly pueblos, but no one owned anything. No one owned the roads. No one owned, you know, the houses that were there.
I think
Now that there's a race going on as to who's going to own the moon, whether the US or China is going to try to take ownership of the moon. It's crazy.
Right.
So bizarre.
Right. So,
I think Native Americans also had, and a lot of indigenous people, a sense of stewardship. That the earth wasn't anybody's to own or keep.
you would
or
rent
just
it.
to use,
You're just
but to take care of.
yeah.
You know, and so they do things like I have a friend, she's a labyrinth person who her husband bought some land out in Missouri and they wanted to return it to wild grass, you know, after it had been a soybean farm, which is really bad for the earth. And they had a hell of a time restoring the wild grasses that grew there originally. And finally, she ran into somebody just kind of randomly who was a Native American. And he said, well, you have to burn it every 7 years. And so now they do that on the land that they have. She has this huge labyrinth. It's like an acre across on this, you know, giant farm plot. And they have a group of people come and do this ritual burn every 7 years because it helps the grasses grow. So it's not just that it grows wild and you just leave it alone. They had a sense of participation in the process that helped to make it healthy.
Sure.
And so that sense of stewardship, I think, is really lacking in our culture. We just feel like it's ours to destroy.
Marjorie, here in the South, it's customary to burn palmetto underbrush under trees. So you see fires and you see the trunks and the bases of trees and it all gets black and then it gets renewed and it comes back. But that's how they manage the forests around here.
I didn't know that.
So,
And I believe that comes from the indigenous people.
yeah, it probably does. I mean,
It's just that it's just natural fertilizer. Instead
Right.
of throwing fertilizer down, you're just
yeah.
burning it all to put
the-
nutrients back in the ground.
Right, and it gets the acid base balance back and balance and
So interestingly, for both the Hawaiians and Native Americans, the sense of stewardship and lack of ownership is really the root cause of why all of their civilizations failed relative to European takeover of their land. Because the Europeans brought a sense of ownership.
right.
And it was so foreign to Native Americans, including the Hawaiians, that they just couldn't comprehend why you wouldn't share the earth.
Right.
And that's what, I mean, basically it was a land grab for them for the Europeans, because they couldn't understand, they didn't understand the native way and the natives didn't understand the Europeans.
Right.
Well, I guess they naturally understood the oneness, and then ownership kind of breaks that sense of oneness, that connectivity of oneness that they just naturally understood. You know, they didn't feel separate from the land, you know, per se.
Right.
They were just part of it.
Right.
Also, I think ownership is an important part of capitalism.
Mm. Yeah.
Like ownership means you can borrow and have money.
If you have an asset, then you can borrow against it to get That
Yeah.
would, but again, the natives, the Native Americans didn't have a notion of money per se. They had, you know, trading of different sorts, but there wasn't really a capitalist structure in place.
Well, I think they weren't always trying to get the whole pie. They were also trying to make a bigger pie for the whole group. You know, and so they would put more in rather than trying to take it all out.
Right.
They would put more in for everybody because the idea was for everybody to benefit.
Right.
And now that's so foreign.
Yeah.
That should be part of a corporate purpose, is to provide a livelihood.
Right.
You know,
Yeah.
my 2 cents.
Anyway, I'm gonna move on at this point, and I'm gonna cover what Ron dealt with a lot. He was fascinated with how the universe came to be. And the way that he described this to me was that his soul was able to hold memories back to a fraction of a second, a half a second, a quarter of a second, something like that. But when they went back that far, then he was able to link to the memories that went back another half a second or 3/4 of a second, and so forth. So he simply regressed in his memories of his soul, going back to when he saw the universe actually being created. So I said, oh, this is great. So let's go back and look at the Big Bang. And he said, no, there wasn't any Big Bang. There was a big bounce. There wasn't any fireball or, you know, I don't know what you're talking about. And, you know, that's what we're going to try and cover here, is this whole area of cosmology, which for modern science is relatively new, in the sense that we finally started to have telescopes around 1900 that could go far enough out into space, gather enough light to see distant objects. And the distant objects turned out not to be simply stars, but other galaxies. And then that started to be a tip-off as to how big the entire universe might be. But it's a relatively new area. It's only, you know, really since the year 1900 that this has kicked in, and therefore a lot of the findings, if you will, you know, have to be taken as working hypotheses. It's not there's observations, but then there's how you interpret the observations is so critical. So what we have. We you know, just to contrast this, if we go into the Hindu Akashic records, we find a description of a cyclical universe, of it being created and then it grows and expands and then collapses on itself and creates itself again. That's very clearly there in Hinduism. You know, the thing that we find when we go into, I'll just pull this up here, hold on a second, into the Bible. Here it is. Hold on. I'll do a share screen here. So we had the King James Bible has a description here of Genesis. And what in the world does Genesis say? It says, in the beginning, hold on, God created the heavens and earth. The earth was without form and void, and darkness was on the face of the deep. And the Spirit of God was hovering on the face of the waters. And God said, let there be light, and there was light. And God saw that the light was good. and God separated the light from the darkness, and God called the light day, and the darkness he called night, and there was evening and there was morning the first day. So there's actually a lot of truth in this from Western science. We end up having a void. There's light and darkness, and in the analysis that people have done of the so-called Big Bang, there's lots of light initially, and then things cool down enough so that it's no longer so hot that the actual plasma that's there in space ends up cooling enough so that you can actually have light propagate. And so there's a void. There's light, which was this original supposed fireball, and then there was nothing. There was darkness, and then there was light, and so forth. So there might be something to what we get in Genesis. Okay. Now the thing that I'm going to come back to, but I liked was this story by Isaac Asimov that we touched on before. But let me leave that for the time being, and we're going to go back and just survey. There's hold on one sec. Let me pull it up. Here it is. There's a nice little historical survey of what would be called modern Western cosmology. And it's a nice little PBS thing. So here we go.
What is the nature of the universe? How's that for a question? For a long time, we humans had no idea what was going on in the universe. To help, we made up stories to either help us explain what we saw or to make us feel better about what we didn't understand. But then science came along and we started to understand more. We could test our ideas, and as we got more confident in the process, our ideas grew. The field of cosmology was born, the study of the cosmos itself. And now, after centuries of speculation and just so stories, we're starting to get a grasp on the biggest ideas there are. What is the nature of the universe? Let's find out. By the turn of the 20th century, scientists knew the Earth was old. Darwin's theory of evolution strongly implied the Earth was at least millions of years old, and Lord Kelvin, a hugely respected physicist and engineer, confirmed the Earth was ancient, given that it must have cooled from an initially molten state. That takes a while, at least 1 million years. How old exactly, no one knew. As for the universe itself, it logically must be as old or older than Earth. A popular model for the universe was that it was static. It is and always has been as we see it now, and in general hasn't changed. Stars may be born and they may die, but overall things pretty much stayed in balance. The universe always existed, always will, always had galaxies in it, and so on. There are variations on this idea, but that's it in a nutshell, and it's what many astronomers believed. This is important. When we try to understand observations in astronomy, we fit them into a framework of understanding, things we think we already know. When something doesn't fit, it's a problem. Maybe the observation is wrong, or maybe we're misinterpreting it, or maybe the framework is wrong. That's a big step to undertake and needs proper contemplation and skepticism. Science is a tapestry, and when you yank at one thread, the whole thing may need reweaving. Sometimes, rarely, but sometimes, you have to yank that thread. The thread that got pulled in this picture was first uncovered in 1912. That was when astronomer Vesto Slipher, who has the uncontested coolest name for an astronomer ever, started taking spectra of the so-called spiral nebulae, hoping to get some insight on their characteristics. Remember, this was before we understood what galaxies actually were. It took him several years of observations, but by 1917, he had observed 25 of them, and he found something astonishing. When he examined their spectra, he saw that almost all of them were highly redshifted. In other words, it looked like most of these objects were rushing away from us at high speed, millions of kilometers per hour. What could that mean? At this point, two different lines of work began to converge. One was by a Belgian theoretical physicist named Georges Lemaitre. In the 1920s, he had been studying Albert Einstein's work, the equations dealing with the behavior of the universe as a whole. Einstein had concluded that the universe was static, unchanging, but Lemaitre disagreed. He found that an expanding or contracting universe fit the equations better. And given the redshifts observed by Slipher, he proposed the universe itself was getting bigger, which is why the galaxies appeared to be moving away from us. Another brilliant physicist, Alexander Friedmann, had also reached the same conclusion. At the same time, astronomers were trying to determine the distances to the nebulae, now understood to be galaxies in their own right. As I mentioned in our first episode about galaxies, Edwin Hubble and his assistant Milton Humason were at the forefront of this. They observed variable stars in the Andromeda Galaxy that allowed them to get the distance to the galaxy. They then observed some of the same galaxies Slipher did and measured their distances. When they compared distances to the redshift Slipher observed, they found that the farther away the galaxy was, the faster it was moving away from us. Let me repeat that because it's kind of important. The farther away a galaxy was, the faster it appeared to recede from us. Some other astronomers had also found similar results, but the work of Hubble and Humason clinched it. We now know it to be true for every distant galaxy we observe. They are all redshifted, all heading away from us. And this ties into what Lemaitre had concluded. The universe is expanding. Wait, what? The universe is getting bigger? How can that be? What does that even mean? There are lots of different ways of looking at this. Lemaitre himself suggested imagining the cosmic clock running backwards. Right now, as time inexorably marches on, all the galaxies in the sky are getting farther and farther away from us. But that means that in the past, they were closer together. Run the clock back far enough, and they get closer and closer together until at some point in the past, everything in the entire universe was crammed together into an uber-dense thing. That is a really, really weird thought. It's hard to imagine everything in the whole cosmos, every star, nebula, galaxy, every atom, electron, and proton, all squeezed together into one infinitely dense blob. But that's what the observations are telling us. Lemaitre called this a primeval atom, or more colorfully, the cosmic egg. Fair enough, but this has implications. If you squeeze all the energy everywhere into one place, that place is going to be hot. When the universe was a tiny dot, it would have been unimaginably, hellishly hot. Then, for some reason, it suddenly expanded violently and started cooling. This sounds an awful lot like an explosion. Bang! Involving the entire universe, which is big. What else would you call this, Bud? The Big Bang. In fact, the term became popular when astronomer Fred Hoyle used it on a radio show and later in a widely read magazine article. Ironically, he meant it somewhat disparagingly since he didn't think the Big Bang model was correct. To his and many other astronomers' chagrin, the name stuck. I like it. It's not perfectly accurate, but it's succinct. Again, this is all pretty strange, and astronomers had a hard time accepting it. After all, it went against everything they thought was true at the time. In science, though, a hypothesis needs to make testable predictions before it can be taken seriously. What predictions could the Big Bang model of the universe make that we can observe today? The speed of light is fast. 300,000 kilometers per second, or about 1 billion kilometers per hour. Like I said, fast, but not infinitely fast. The sun is 150 million kilometers away. It takes light about 8 minutes to reach the Earth. So in a sense, you're seeing the sun as it was 8 minutes ago. The nearest star system to us is Alpha Centauri, 4.3 light years away. So we see it as it was 4.3 years ago. The Andromeda Galaxy is about 2.5 million light years away. The light we see from it now left that galaxy when Australopithecus walked the Earth. The farther away something is, the farther in the past we see it. This is called the look-back time, and it's a crucial tool for cosmology. By observing very distant objects, we can see the universe when it was young. You might think that we could see all the way back to the moment of the Big Bang. But there's a problem. At some point back in time, the universe was so hot and dense that it was the same temperature as the surface of a star. It would have been very luminous, but also opaque. As it expanded, it cooled and became transparent. If we look back far enough, that moment in time when it cleared up is as far back as we can see. What does that moment look like? By looking at the physics of the Big Bang, the math that describes how matter, energy, space, and time behave, astronomers could predict when this moment happened in the lifetime of the universe, a few 100,000 years after the bang itself. Using the idea of look-back time, they could predict how far away it would be from us and therefore calculate its redshift. Remember, redshift stretches the wavelength of light. The light the universe emitted at the time would have been like a star in the visible part of the electromagnetic spectrum. But the light that reaches us billions of years later, now, should be redshifted into microwave wavelengths. In 1965, a pair of radio astronomers announced they had found a signal in their radio telescope that was like a background noise coming from everywhere in the sky. They tried everything they could to explain it, including scraping out the bird poop inside their radio telescope in case that might be causing it. But the only thing that made sense was that this was indeed the redshifted light from the early universe. They had discovered the glow of the fireball left over from the birth of the cosmos. Later, in the 1990s, satellite observations further refined the measurements of this cosmic microwave background, and now it's essentially confirmed. This glow was successfully predicted by the Big Bang model, and now we see it in exquisite detail. Its discovery was a huge step in cosmology. The redshift of distant galaxies and the cosmic background are not the only confirmations we have that the Big Bang model is correct. For example, the model also makes predictions about the elements we see in the universe. At first, when the universe was dense and hot, only subatomic particles could exist. But as the universe cooled for a brief time, they could fuse and form heavier elements. The Big Bang model predicts certain abundances of elements, ratios of them compared to hydrogen, and that's just what we see in the universe at large. Also, the sizes and shapes of the largest structures in the cosmos are in line with what a Big Bang model predicts. There's lots of other observational evidence as well. Pretty much every modern astronomer on Earth understands that the Big Bang model of how the universe got its start is the correct one. But what does it mean? I mean, physically, it's a very common misconception that the Big Bang was an explosion in space with everything rushing away from some point. But that's not what's really happening. Remember, I've talked about space being a thing in which matter and energy exist. Space can be warped or bent by mass, creating what we think of as gravity. When we talk about the universe expanding, we mean space itself is expanding, and when it does, it carries galaxies along with it. In a sense, it's like having a rubber ruler. When you pull on it, it gets longer, and the distance between the tick marks gets wider. When the ruler doubles in length, the tick marks that started out a millimeter apart are now 2 millimeters apart. But tick marks that were 10 centimeters apart are now 20 centimeters apart. In other words, the farther away a tick mark is, the faster it appears to move away. Sound familiar? That's just what galaxy redshifts are telling us. It also means that really the galaxies aren't actually doing any moving. It's that space between them is expanding. This may seem like a nitpicky semantic point, but it's physically true. The galaxies are, for all intents and purposes, standing still. The space in between them is where all the action is. And it gets even weirder. This is true no matter where you are in the universe. From any galaxy, it looks like all the others are rushing away from you. Look back at that ruler. No matter what tick mark you start with, when the ruler stretches from that spot, it looks like the tick marks are all moving away from you. This is what Einstein's equation showed and what Lemaitre saw in them. Space is expanding. But that means the Big Bang wasn't an explosion in some pre-existing space. It was the initial exploding expansion of space itself. The universe isn't expanding into anything because it's all there is. There's nothing outside the universe for it to expand into. This also means the universe has no center, no point of origin. Imagine the ruler is now a circle and the diameter is expanding. No tick mark is the actual center, yet no matter where you are on the ruler, every tick mark appears to move away from you. In a similar way, every spot in the universe appears like the center, which means none is. No place in the universe is more special than any place else. We're all in this together. It can be hard to grasp, and I'll admit we all have some difficulty with these concepts, but the math bears them out, and so do essentially all the observations we make of the distant universe. And in all this weirdness, don't lose sight of the big picture. The universe had a beginning, and we can see evidence of it. Not only that, but by measuring how quickly it's expanding, we can use math to run the clock backwards and determine the age of the universe. Currently, the best measurement we have of the age of the universe is 13.82 billion years. Or perhaps I should say 13.82 billion years. That's an amazing number. It's a long, long time, 3 times older than the Earth. But what gets me is that we can figure it out at all. Pretty smart, us apes. Today you learned that distant galaxies show a redshift in their spectrum, which means they're moving away from us. The universe is expanding. This means it used to be hot and dense, then it started expanding and cooling. This model of the universe's early behavior is called the Big Bang, and it was confirmed when the background radiation, the glow of the fireball, was detected in the 1960s. Other lines of evidence support it as well. Using this information, we have measured that the universe is nearly 14 billion years old. Crash Course Astronomy is...
So there you have what was good for probably up to 20 years ago. And, you know, let's just take a look at some of these other videos. One of the things he just touched on was in the late 70s, this classmate of mine, Alan Guth, was trying to understand why the stars in the sky all seem to be so uniformly spread out. There's no clumping together of the stars in one area and no stars in another. The stars are just spread out everywhere. And he came up with this notion of you know, what would be called the phase change. So we have ice, and when ice melts, it turns into water. So water changes phase from being a solid to being a liquid. Or if the liquid gets heated up enough, it becomes a gas. So that's a phase change. So he said maybe there was some sort of phase change at the start of the universe, and that led to what he called inflation. So the compartments of space themselves expanded, and they expanded by 30 orders of magnitude. He did a great job of coming up with this idea. One of the problems he had was he couldn't figure out how to turn it off. Once it got going, he didn't have any mechanism for shutting it down. And that led to people thinking about this and coming up with a lot of other ideas. Ron Cowan, in his observations, when he went back to the start of the universe in the epoch that we're in, actually saw these space compartments and saw them expand or inflate just the way Alan Guth predicted. So that much is clear based on this memory that that he came up with, that Ron came up with. But the thing to keep in mind is there was a lot of other things along the way that led to issues with this. And I'm just going to touch on, here's a survey of these issues from Paul Steinhardt, who's at the Princeton physics department. So let's listen to Paul. And he was very active in.
My name is Paul Steinhardt. I'm at Princeton University. The inflation model is an attempt to solve a fundamental problem with the original Big Bang picture. The Big Bang is not something we really deeply understand. We have no theory of the Big Bang, but our notion is that it's some random, highly turbulent quantum beginning from nothing to something. And so it would leave a universe which is very random and distorted. So yet we don't observe that's the way the universe looks today. So we need some idea to fix that. So inflation was invented as a fix, as a brief period of extremely rapid expansion that would occur after the bang, whose purpose would be to smooth out those initial highly uneven distribution of matter and radiation. So I was actually, my own career in cosmology began with the idea of inflation. I was really attracted by this notion that you could solve these fundamental problems about the universe through some kind of transition, brief transition that would occur over a very short period of time in the early universe. So originally I was a big fan of it, and I think it's fair to say that I made a number of contributions constitute the idea today. But in the process, I also learned some things about inflation that turned out to be very unattractive. And we assumed that quantum effects played a very minor role. But we discovered over time it's reverse. Quantum effects completely dominate what happens once inflation starts. So even though you thought you were smoothing the universe, there are also quantum effects that unsmooth it. And the unsmoothing wins out over the smoothing. This inflation that occurred in the very early universe that not only smoothed the universe, but also produced a little, what first of all thought was a small amount of de-smoothing that would produce hot spots and cold spots in the early universe. So you should also expect to see along with this gravitational waves that accompany all those fluctuations that you produced in the distribution of matter and energy. But we don't see those. The Big Bang is this period in which quantum physics dominates over classical. So you might wonder, is it possible to construct a theory of the universe in which you don't have a bang? And in which you never have a period in which quantum physics dominates over the classical. That universe is, in terms of its average properties, always following deterministic equations, classical equations of motion. And that's the idea that we're pursuing. That instead of a bang, there was a bounce. That the universe underwent a very long period of contraction. It's during this period of contraction that you can smooth and flatten the universe. And quantum fluctuations in this case will produce hot spots and cold spots, but not ones that produce a quantum runaway effect. One of the things I find appealing about the bounce idea is that there it has a natural role. If you imagine that the universe didn't just bounce once, but bounced at regular intervals, why would there be one bounce? Why wouldn't it repeat? All the lumpiness and randomness that we see here in the universe today somehow has to be smoothed out before you get to your next bounce in preparation for the next bounce. Dark energy is a natural mechanism for producing that. Given by an energy which is very, very close to zero, just on the edge of going from positive to negative. The fact that it's slightly positive right now means that it is causing this accelerated expansion. But it's also easy to imagine that it's slowly decreasing in its concentration. And if it decreases and goes from slightly positive to slightly negative, that will automatically cause the expansion of the universe to go from accelerated expansion to decelerated expansion, and then to turn around and go to contraction. What I remember is that my father used to tell me, bedtime stories like, sometimes it'd be Jack and the Beanstalk, but sometimes it'd be the story about a scientific discovery. So I remember us telling me stories about Madame Curie and Louis Pasteur and stories, and the stories always, led to this dramatic moment where there'd be this moment of discovery, and that to me was the really, exciting point. And I just wanted to know if I could ever do anything like that, discover anything new that people didn't know before, which is somehow the strange job of a scientist. And so, yeah, I was hooked.
Okay, so there you have a short little summary of what why people think there wasn't a bang but a bounce. And the thing to keep in mind is there wasn't any bang. If there was a bang, you would have heard it. But there's nothing around. There's no sounds you're going to hear in this thing. So that's number one. The second thing is it's not big, because people envision all of this stuff coming together into something, the size of, a large basketball. Hard to imagine how the entire universe would end up in a large basketball, but that isn't big. So there's no big and there's no bang. That's what you get out of this. And the other side to it, though, he mentioned these quantum effects, and the original work that Alan Guth had done were all with classical, not quantum theory. But what Ron Cowan observed was he actually observed the space compartments themselves, which are the smallest granularity you can get, spaces of home around us. And the space itself expanded very rapidly. So the inflation side, as Ron observed, it was correct, okay? And the dark energy that he saw there, I believe, is the energy that's contained in the walls of the space compartments. And so apparently this energy, bounced, it took everything out, and but it's apparently gradually running out of oomph, and at some point will turn negative and things will come back and collapse on themselves. But that'll be trillions of years from now, so we don't need to worry about it. So I just want to close out here with one other video, and this is from Roger Penrose, who received the Nobel Prize in Physics for all of the theoretical work he did, and he was the one who really advocated, started in 2005, that there were these cycles to the universe. So let's hear what he has to say.
Or yes, that singularity.
Well, I was just thinking to myself, how boring this universe is going to be. You've got this exponential expansion. This was discovered early in this century, 21st century. People discovered that these supernova exploding stars showed that the universe is actually undergoing this exponential expansion. So it's a self-similar expansion. And it seems to be a feature of this term that Einstein introduced into his cosmology for the wrong reason. He wanted a universe that was static. He put this new term into his cosmology to make it make sense. It's called the cosmological constant. And then when he got convinced that the universe had a big bang, he retracted it, complaining that this was his greatest blunder. The trouble is, it wasn't a blunder, it was actually right. Very ironic. And so the universe seems to be behaving with this cosmological constant. Okay, so this universe is expanding and expanding. What's going to happen in the future? Well, it gets more and more boring for a while. What's the most interesting thing in the universe? Well, there's black holes. The black holes more or less gulp down entire clusters of galaxies. The cluster, it'll swallow up most of our galaxy. We will run into an Andromeda galaxy's black hole. That black hole will swallow our one. They'll get bigger and bigger, and they'll basically swallow up the whole cluster of galaxies. Gulp it all down. Pretty well all. Most of it. Maybe not all. Most of it. And then that'll happen to, there'll be just these black holes around. Pretty boring, but still not as boring as it's going to get. It's going to get more boring because these black holes, you wait, and you wait, and you wait, and you wait an unbelievable length of time. And Hawking's black hole evaporation starts to come in. And the black holes, it's incredibly tedious. Finally evaporate away. Each one goes away, disappears with a pop at the end. What could be more boring? It was boring then. Now this is really boring. There's nothing, not even black holes. The universe gets colder and colder and colder and colder. And I thought, this is very, very boring. Now that's not science, is it? But it's emotional. So I thought, who's going to be bored by this universe? Not us, we won't be around. It'll be mostly photons running around. And what the photons do, they don't get bored because it's part of relativity, you see. It's not really that they don't experience anything, that's not the point. That photons get right out to infinity without experience any time. It's the way relativity works. And this was part of what I used to do in my old days when I was looking at gravitational radiation and how things behaved in infinity. Infinity is just like another place. You can squash it down as long as you don't have any mass in the world. Infinity is just another place. The photons get there. The gravitons get there. What do they get? They run to infinity. They say, well, now I'm here, what do I? There's something on the other side, is there? The usual view is just a mathematical notion. There's nothing on the other side. That's just the boundary of it. A nice example is this beautiful series of pictures by the Dutch artist M.C. Escher. You may know them. The one's called Circle, and it's a very famous one with the angels and the devils. And you can see them crowding and crowding and crowding up to the edge. Now, the kind of geometry that these angels and devils inhabit, that's their infinity. But from our perspective, infinity is just a place. Okay,
sorry, can you just take a brief pause?
Yes.
And just the word you're saying, infinity is just a place. So for the most part, infinity, sort of even just going back,
Yes,
infinity is a mathematical concept.
I think this is one
You
of
think
the
there's an actual physical manifest, like in which way does infinity ever manifest itself in our physical universe?
Well, it does in various places. You see, it's a thing that if you're not a mathematician, you think, oh, infinity, I can't think about that. Mathematicians think about infinity all the time.
Yeah.
They get used to the idea and they just play around with different kinds of infinities and it becomes no problem. But yeah, you just have to take my word for it. Now, one of the things is, you see, you take a Euclidean geometry. Well, it just keeps on going, and it goes up to infinity. Now, there's other kinds of geometry, and this is what's called hyperbolic geometry. It's a bit like Euclidean geometry, so it's a bit different. It's like what Escher was trying to describe in his Angels and Devils. And he learned about this from Coxeter. And he think that's a very nice thing. I try and represent this infinity to this kind of geometry. So it's not quite Euclidean geometry, it's a bit like it, that the angels and the devils inhabit. And their infinity, by this nice transformation, you squash their infinity down, so you can draw it as this nice circle boundary to their universe. Now, from our outside perspective, we conceive their infinity as this boundary. Now, what I'm saying is that it's very like that. The infinity that we might experience, like those angels and devils in their world, can be thought of as a boundary. Now, I found this a very useful way of talking about radiation, gravitational radiation, and things like that. It was a trick, mathematical trick. So now what I'm saying is that that mathematical trick becomes real. That somehow the photons, they need to go somewhere, because from their perspective, infinity is just another place. Now, this is a difficult idea to get your mind around. So that's why one of the reasons cosmologists are finding a lot of trouble taking me seriously. But to me, it's not such a wild idea. What's on the other side of that infinity? You have to think, why am I allowed to think of this? Because photons don't have any mass. And we in physics have beautiful ways of measuring time. There are incredibly precise clocks, atomic and nuclear clocks, unbelievably precise. Why are they so precise? Because of the two most famous equations of 20th century physics. One of them is Einstein's E equals mc squared. What's that tell us? Energy and mass are equivalent. The other one is even older than that, still 20th century, only just. Max Planck, E equals h nu. Nu is a frequency, h is a constant again like c, E is energy. Energy and frequency are equivalent. Put the two together, energy and mass are equivalent, Einstein, energy and frequency are equivalent, Max Planck. Put the two together, mass and frequency are equivalent. Absolutely basic physical principle. If you have a massive entity, a massive particle, it is a clock with a very, very precise frequency. It's not, you can't directly use it, you have to scale it down. So your atomic and nuclear clocks, but that's the basic principle. You scale it down to something you can actually perceive, but it's the same principle. If you have mass, you have beautiful clocks. But the other side of that coin is, if you don't have mass, you don't have clocks. If you don't have clocks, you don't have rulers, you don't have scale.
So you don't have space and time.
You don't have a measure of the scale of space and time.
Scale
So you
of
have
space and time.
you do have the structure, what's called the conformal structure. You see, it's what the angels and devils have. If you look at the eye of the devil, no matter how close to the boundary it is, it has the same shape, but it has a different size. So you can scale up and you can scale down, but you mustn't change the shape. So it's basically the same idea, but applied to space-time now. In the very remote future, you have things which don't measure the scale, but the shape, if you like, is still there. Now that's in the remote future. Now I'm going to do the exact opposite. Now I'm going to go way back into the Big Bang. Now as you get there, things go hotter and hotter, denser and denser. What's the universe dominated by? Particles moving around almost with the speed of light. When they get almost with the speed of light, okay, they begin to lose the mass too. They're for a completely opposite reason. They lose the sense of scale as well. So my crazy idea is the Big Bang and the remote future, they seem completely different. One is extremely dense, extremely hot. The other is very, very rarefied and very, very cold. But if you squash one down by this conformal scaling, you get the other. So although they look and feel very different, they're really almost the same. The remote future, on the other side, I'm claiming is that where do the photons go? They go into the next Big Bang. You've got to get your mind around that crazy idea.
Taking a step on the other side of the place that is infinity. Okay,
Yes.
but
So I'm saying the other side of our Big Bang, now I'm going back into the Big Bang.
back
There was the remote future of a previous eon.
previous eon.
And what I'm saying is that previous eon, there are signals coming through to us which we can see and which we do see. And these are both signals. The two main signals are to do with black holes. One of them is the collisions between black holes, and as they spiral into each other, they release a lot of energy in the form of gravitational waves. Those gravitational waves get through in a certain form into the next eon.
That's fascinating that there's some, I mean, maybe you can correct me if I'm wrong, but that means that some information can travel
Yes,
from another eon.
exactly.
That is fascinating. I mean, I've seen somewhere described sort of the discussion of the Fermi paradox. You know, that if there's intelligent life,
Yes,
being, communication immediately takes you there. So
we have
do
a
you think-
paper. I have my colleague Fahir Gurzajan, who I worked with us on these ideas for a while. We have a crazy paper on that. Yes.
So
Looking at the Fermi paradox. Yes.
right. So if the universe is just cycling over and over and over, punctuated by the singularity of the Big Bang,
Yes.
and then intelligent or any kind of intelligent systems can communicate through from eon to eon. Why haven't we heard anything from our alien friends?
Because we don't know how to look.
That's fundamentally the reason. Is
I don't know. You see, it's speculation. I mean, the SETI program is a reasonable thing to do, but still speculation. It's trying to say, okay, maybe not too far away was a civilization which got there first, before us, early enough that they could send us signals. But how far away would you need to go before? I mean, I don't know. We've so little knowledge about that. We haven't seen any signals yet, but it's worth looking. It's worth looking. What I'm trying to say, here's another possible place where you might look. Now you're not looking at civilizations which got there first. You're looking at those civilizations which were so successful, probably a lot more successful than we're likely to be by the looks of things, which knew how to handle their own global warming or whatever it is, and to get through it all and to live to a ripe old age in the sense of a civilization, to the extent that they could harness signals that they could propagate through for some reason of their own desires, whatever we would know, to other civilizations which might be able to pick up the signals. But what kind of signals would they be? I have the foggiest.
Okay, so there you have a couple of different points of view. Let me just try and go to, just going to try and pick up on really what Ron, let me see, is it down here? No, hold on. What Ron actually saw, he did see the space compartments expand, and he did see hints of what was from the earlier bounce, okay? But really what he saw was much more what came up in Isaac Asimov's short story, The Last Question, which we touched on. And I'll just remind you what Asimov said. There was a computer, which he called Multivac, that was going to actually run the entire planet Earth. And they ended up asking, when they cranked up Multivac, they asked the same question, how can the net amount of entropy in the universe be decreased? And Multivac answered, I don't have enough information to answer this. I mean, the story goes through again and again, leaping forward in time into later eras, always asking the same question. And again, the computer always answers, I don't have enough information to answer, insufficient data for a meaningful answer. And so we finally get to, at the very end, now the computer is off into hyperspace, wherever that is. And there's all of these trillions upon trillions upon trillions of humans, and the stars have been flickering out. And when Asimov wrote this, there really wasn't any notion of black holes. So he left that out, but as you saw, Penrose said, even the black holes are going to disappear. They're going to evaporate or flicker out. And so finally, the very last person that was there asked, could you answer this question about reversing entropy, all of the humans had all uploaded themselves into the computer. And so the computer sat there for now a very long period of time, but there is no notion of time because there's nothing going on anywhere. And finally, the computer discovers the answer off in hyperspace and realizes how to reverse entropy, but he has no way, or she has no way to report this since no one's around. And so the computer says, let there be light, and there was light. So, there's more right than wrong in this, okay? It's crazy how close Asimov was. And this is what Ron Cowan saw too, that again, we have what was missing from the story is that there's a black hole in the middle of each galaxy. These black holes will continue to expand and vacuum up stars. Our galaxy has a black hole that's 4 million stars in mass. So if we took the sun as one solar mass, it has 4 million suns sucked into it. And there's probably 100 billion stars in our Milky Way galaxy, and it's going to vacuum all of them up, apparently. And that'll be the end of the Milky Way galaxy. Now we have life here. We have matter, which is us, and we have the dark matter or shadow matter or mind forms that are these chakras, so that live forever. And so they're linked with us, and the dark matter is what's there all the time. So eventually all the stars are going to disappear and all the black holes are going to disappear. And just these souls that we have are going to be in a separate subspace from the subspace of matter. And there'll be no notion of time. Time will just cease to exist, as Penrose pointed out, because there's no way to measure it. There's nothing going on. So he took this idea, and eventually things will collapse, and the thing that'll be left there will be space compartments, and these dark matter entities will be compactified into these crunched space compartments, and they'll bounce. And the thing that drives them apart will be the energy from the bounce that's contained within the walls of the space compartment. And so it goes. And this will repeat again and again and again. And so it goes. So with that, I want to close out what Ron saw. And I'm going to turn things over, unless there's any questions, turn things over to Marjorie.
Any questions?
Any questions anyone has?
I have a question.
Yeah.
So, the idea of the bounce is that there's an expansion and a contraction that repeats. Is that correct?
Correct.
And
let me just pick up on that so you understand. The walls of the space compartments of space, which is all around us, the foam of space, that has energy, but the energy can flip from being expansive to being contracting. And so at some point going forward in time, it's just going to flip on us and everything's going to go shrink.
But the idea is, since so there's a static nature then to the universe, what's happening is the position, the ratio of all objects in the universe to one another would remain static, but the space itself between the objects is expanding and contracting, thereby maintaining the same ratio. Is that accurate?
Yeah, that's what's going on. Yeah.
And where do the black holes fit in? They see
the black holes are simply, you can end up with these stars when these stars go into these novas or whatever. It's possible to create in the incredible explosion that's there a black hole, and so the black hole will, because it's black, it'll start to suck up things around it. And if there's enough of it, attracts enough stuff, it'll grow bigger and bigger, except that you won't see it because it's black. That's the only new wrinkle in this. Okay, you could think of how to say it. When Einstein was working on his general relativity, he came up with the notion of these black holes, which he simply discounted. He just said that they couldn't possibly exist, but we've now observed them through modern telescopes in the middle of every galaxy that we can find. There's one galaxy that doesn't have a 4 million solar mass black hole. It has 100 billion solar mass black hole. It's just inconceivable what that is. So, you know, it's just part of the landscape.
And they have this incredible gravity, right?
Yeah, well, you can't escape from it. Light can't escape. You can't escape from it. If you get too close, you're gone. So.
But information can escape from it.
What did you say?
Information can escape.
Yeah, the information can escape, but that was something that was overlooked. And the information escaping is what will lead to the black hole eventually evaporating. Even though they're growing right now, they're also shedding this information. But
and is that what drives the expansion and the contraction
of the black hole?
Yeah.
Yeah, that's what makes the black hole do what it does.
Well, but it's what makes the universe expand and contract.
Well, no, the universe is driven by the energy that's in the fabric of space itself, in the compartments that make up the space, the foam of space. That the different particles reside in. That has the energy, and that has the algorithms for controlling everything. And so
that's just this rhythm.
And so right now it's in the expansion phase, and at some point it's going to flip to the contraction phase, but we won't be around to worry about that.
But the black holes don't have anything to do with that per se.
No, they will obey this. The black holes are simply in the fabric of space and time, so they're along for the ride. Some people think going through the black holes will take you, like to other alternative universes, because there's a lot of evidence that there are other universes besides our universe that are doing exactly the same thing all around us.
Those might be the wormholes and the Calabi-Yau manifold that could be the universe.
Right.
A wormhole does not equal a black hole, does it?
No. A wormhole is different, but it could lead to the creation of a wormhole.
Right.
The concept currently is that mass cannot go faster than the speed of light. Is that accurate?
Mass, the mass that we have, can't go faster than the speed of light in the 3 space and 1 time dimension we're in. But there are other, how to say it? Did you ever see, there was a science fiction movie where they used wormholes to show that you could go faster than the speed of light if you went through the wormhole and lived to tell about it. I'm trying to remember, what was the name of Interstellar? That was the name of the movie, Interstellar.
Does energy have a similar concept of movement that mass does?
Well, energy is what he said. Energy is mass, energy is vibrations.
No, I understand that part. That's kind of where I'm going to, but mass as we know it, with our dimensional reality as we know it, has a limitation in terms of how fast it can go. I'm curious as to whether energy would have any similar limitation.
Yeah, no, in the space time that we're in, that's true. But remember, if I change the actual curvature of the space time, it could indeed be possible to go faster than what we think of as the speed limit, the speed of light. Okay.
But that would be sort of like taking a shortcut, if you will. That the distance from here to there is 100 miles, but there's this shortcut which makes it only 50 miles, and you end up getting there in half the time, so you went twice the speed. That's just kind of a trick. No, but I'm just asking theoretically, if energy did not have the same limitations in terms of movement, speed.
No, it does. It does. It has the same limitations. The energy, again, can't go faster than the speed of light. But as you just pointed out, if we jiggle space-time, we do something to curve it in some crazy way, then it could go faster.
I'm just my thought is that if you can find any kind of equivalence between energy and mass and frequency, then finding a way to shift the frequency of mass would shift its properties to some degree. Were the properties,
I think think of it this way, that you keep the energy or mass or frequency. That's like a given. Okay. The problem is this: if I go jiggle or curve space and time so that I can get between these 2 points much faster, then I have to worry about killing, because I've now effectively torqued or warped or whatever you want to call it, the space-time that's in the way, and I can rip to shreds your body or your mass or your frequencies or your, whatever it is, the energy that's there. So there's a lot of engineering to go answer this question, which has yet to be done.
If every universe has a black hole.
Every galaxy.
Every galaxy. So eventually you could say that they'll end up swallowing each other and becoming one massive, maybe.
Yeah, they could be forming one gigantic black hole, but then remember, there's nothing else around at some point. The stars are all gone. There might be just, one gigantic black hole, but it will evaporate. Okay, with this information.
It wouldn't explode and start all over again.
No, it would evaporate, and there would be absolutely nothing going on. Nothing.
Okay.
So, okay, I'm going to give Marjorie the podium, and what do you want to start with? You want this?
The web.
This.
No.
This? What?
Yes.
Go ahead.
Thank you. I'm going to start kind of in the abstract, and then come down to the particular. So here.
Yeah. Go to there. Here, hold on. Go to this. share screen. Want this?
Yeah,
Okay, now we can just cycle through. Here we go.
okay. So this is picking up on the idea of what the conceptual nature of infinities and whether they're cyclical, and that's part of the infinity is that they recur over and over again. In the tarot, there's this concept of that comes from Kabbalah. Here's the tree of life. In one of the classic tarot cards is the 10 of Pentacles, and the pentacles represent what we think of as physical matter. The swords are thought, the cups are emotions, and fire, the wands are fire, and that's feeling. So they correspond to the 4 Jungian modes and personality types. It's a very, very elaborate system. And the idea is that the suits cycle through the numbers from the ace, which is kind of a paradoxical thing between 0 and 1, which I won't dwell on other to say that, through 10. And that 10 represents the logical conclusion of each of these modes of existence or energy. They're not so much about physical elements as spiritual elements, but we conceive of them that way. So earth, the element earth represents physical realities. This is called a gate card. There are several of them in the deck because the arched doorway here takes you kind of from one dimension into another. So there's this deep space there that is kind of unusual. The woman who designed these was a stage painter, and she was the first one to come up with images for all the suits. And she was a member of the Golden Dawn, along with Yeats and Aleister Crowley and different people, Paul Foster Case. And she and Case worked on this deck together. This is said to represent, the old man is said to represent Ulysses coming home from his wanderings, and nobody recognized him but his dogs. And that's what that's showing. And in the picture, nobody's really looking at each other. They're not really connecting. So that's just part of it. But the suits have a given order, and they represent going from the element of fire is said to be the highest, and the closest to the original source, the divine source. And that represents just like passion, just energy, just as it sounds, fire. And then it goes to the opposite is water, and then thought, and then physicality. So the last card of all these are called minor arcana is the 10 of Pentacles, because it's gone through all the suits, all the elements. So it's the culmination of all of the elements in the culmination of the element of earth. And this is one of the few cards that is blatantly Kabbalistic, because it's showing the tree of life. And there are a lot of people who like to say, oh, the tarot has nothing to do with Kabbalah. You know, it absolutely does. So you could say that each one of these is a kind of like a style of infinity. And so let me see if I can just go to
Yeah, you
the,
can just click to another one. You don't need to just click
I'm
off.
trying. So this is another version of that card with we'll send out these links for you all to see. These all correspond, these all have astrological correspondences as well, which is interesting. It's a system. So here's Aleister Crowley's version with the woman that he painted it with. Both artists were women, of the 10 of Pentacles. And this is a card that actually came up when I was getting the intuition that Bart was coming into my life. So I had these in mind when I was getting the idea. I just can't seem to get there. So do
What do you want to
I
do?
want to lower this down like
Yeah, there you
this.
go.
Okay. So I wanted to do a card that was the 10 of Swords, which I want to actually blow this up a bit and read. These are fairly codified things, but there is room for interpretation as well. So this is Crowley's deck showing the 10 of Swords in that configuration of the Tree of Life. So I believe if anybody's going to do anything innovative in this language, you still have to follow the rules of grammar. You know, you don't get to just make it all up from scratch. Of course, people do all the time, but I don't think they're legitimate. And I don't know that I'm out to create 78 cards in the whole system, but sometimes they come to me. So this represents the 10th Sephirah is at the very end, which is like the final manifestation from the divine abstract, in the suit of air, which represents the intellect. So with the 10 of Swords, the development of human intellect has consequently reached its last step. From the birth of intellect within the ace to complete ruin within the grounds of the 10. Card teaches the lesson that endless fighting ends with destruction, endless analysis with the complete loss of hope and belief. This is like the intellect turned in upon itself, which I think is a distinctly human malaise. It forces the lesson of the 9 of Swords to its inevitable conclusion. And each card is said to be like a mandala that has a teaching story with it, and a lesson. And when the 10 of Swords comes up in a reading, it's one of the hardest cards to break to the person that you're doing the reading for, because it usually indicates the final ending of something. And it's usually hard news for the person to hear. It's not usually what they want to hear. And so we're taught that there is no 11th sword. There's only 10. And whatever or any of the suits, that whatever the matter is coming to its own logical conclusion, just like the universe is expanding as far as it can, and then it's over, you know. So whatever that permutation was is reaching its limit. And the only good news is it's usually a bad ending to a bad situation, and that it's gonna set you free in order to begin something else. So that's really like the lesson with this card, for the most part, especially if it's about a relationship or something, it's usually saying this is the end. And I've had to share this with people. I say, I can't tell you what's going to happen, but this is what the cards are saying, that the situation is at its logical conclusion. So you would be best served to accept that and prepare to move on to something new, and that will be better. So it's better to let go rather than hold on. And people usually don't want to hear it, but I've had quite a few call me later and say, you know, you were right, and that was really good advice, and I listened to it even though I really didn't want to. So here's just the end of this interpretation, which what I like about tarot and astrology is they are open to interpretation, but not all interpretations are valid. So there are rules to follow, and we can call each other on that, and people don't always like that. But you can't just make it up. You know, it's not something to come off the top of your head. So, but with the sun above, it does not lack hope, does not lack every hope, but that would be in the next iteration. It will silently return to its origin again, to the first spark of mind in the ace, and that would logically be in the next suit or the next situation, to start all over again. The big hope in here is that the lessons from the journey absolved won't get forgotten. By the way, every 10 in the minor arcana stands for the end of a process, for the need to restart or at least variate. Only the 10 of swords have an amazingly crude way to put it into words. It's just the way they are. So ultimately, the driving force is transformation. And so I wanted to share with you quickly. I realize we're running out of time. All right, so this is the version of the 10 of swords that I came up with. This was a crystal that was actually an award that was given to my father, that I stuck on the scanner and scanned. I scanned it once and I duplicated it and enlarged it in the tradition of the 10 that you see usually with the 10 of Pentacles. But here I'm using this prism to represent the intellect and the 10 of swords. And that was the meaning that I was going for. And this is the poem that
Marjorie,
belongs
is it-
with it.
excuse me, is there something that we should be looking at that you're referring to?
Yes.
Okay,
So it's
we're not seeing, we're still seeing the,
Oh, wait, we got it. This is on, hold it. Yeah, no, hold on. We've got, you're looking at the 10 swords. We're gonna get out of this.
Thank you.
And we're gonna have to go over to, wait, where did it go? Hold on. Here
There.
it is. This, okay, do you see this now? This is Marjorie's father. There's 10 swords here. Do you see it? 1, 2, 3.
yeah,
4,
yeah, we
5,
see
6.
it now, yep.
Okay, great.
Okay. So that's the image. As I said, I'm not doing 78 of these, but I created this from a scan of a crystal, a cut glass crystal award that was circular on the base, which I stuck on the scanner. And then it was like this pointed pyramid on the top. But from the bottom of the scanner, you're looking up through the bottom of the of the crystal, and then I just repeated it a bunch of times to make the tree of life and added the frame. So these are part of the series. I don't, I have about maybe 15 of them all together. And so I just am trying to find things that kind of jive with whatever we're talking about on the science side. So can you see this poem now? It says God's
Oh, wait,
diamond
no, we
group mind, or do
No,
we
no,
have
no, we
to-
got to get that. That's in a different window. So we got to go out of share screen. Gotta put
I
this
think
up.
you can just have it up, then hit share screen again.
That's what I thought, but we here it is. It just, the problem is it's in an Acrobat window, which is different from
Okay.
a Chrome window.
So do you see the
see-
poem here?
God's diamond group mind.
Yes, yeah, we see it. We see it.
Okay, so I'm just going to read it and you can read along with me. This is my depiction of like the intellect reaching its logical conclusion. So, and this was finished in 1998. So God's diamond group mind, another theory of relativity. Points of view at razor sharp oblique angles, with each slant its own unique line of sight. A shift and parallax ignites a flame. The planes reveal and obscure and divide, multiplying perspectives into faceted reflections, then parsed into prismatic refractions of what? Themselves, each other, what center? The very instrument in question, the only means of investigation. The subject looking back on itself as object sees the proverbial tail here, an ear there, aha, a foot over here. What was the question? Each lens a window leading to a hall of mirrors, a labyrinth of projections, an eyeball peering into a microscope, blinks back through a telescope. A hand turns a kaleidoscope, and I cubed becomes a fly's 16. The truth, the mind concludes, after careful consideration. Reality, it declares after due deliberation. The universe is a bowl of intertwining spaghetti-like strands. Galaxies, come to think of it, not at all unlike those oddly familiar spirals of life-spawning code, coiling and looping back onto themselves, and infinitely varying, yet endlessly repeating, double helixing Möbius strips. Or who the hell knows?
Very nice.
So that's my coda to the evening.
That's great, Marjorie.
Thank you.
Yeah. Now, did this come after the tarot card or before the tarot card that you created? Because they
What do you
feel
want?
like they're connected.
Let's put the image back up, I think.
The image.
This one,
Which one?
this,
This?
yeah. I think I was working on it, on the poem, when the image came to me. But the idea of the light refracting endlessly came from the image.
Wow. It's really neat. It's really, really neat how you, that's so fascinating.
Thank you.
How you, it's like you worked in two different planes and then they came together.
And that's when it's at its best. That's when I feel really blessed to have this as a practice, because each one feeds the other
Yeah.
into new questions for me and new insights and new, it forces me to study more deeply, you know. I wanted to work, I knew I wanted to work with that particular interpretation of the Ten of Swords, which is less situational and more intellectual, for lack of a better word. But that it's that it's about the mind, you know, and the nature of the mind, and how do we move beyond it when we're trying to do that with our mind. But there's the question of consciousness is not just the same as, certainly not the brain.
Mm.
Yeah, true. And we get these glimpses for the most part beyond that. The image that I share with students is in the 70s, when we had the gas crisis, we started in cities, and I lived in New York. The banks had their main floors, their lobbies were often made of marble. You know, they were like these mausoleums, you know, and very symbolic. And then sometimes they were 2 or 3 stories high. So it cost a fortune to heat them. So they started building these artificial ceilings in all the banks that would just go 1 story up. Sometimes you'd still see like the window would keep going beyond these artificial ceilings. And for me, it was around the age of 30, and I think it happens to different people at different points. Your intellect starts bumping up against the ceiling of its own logic. And you have to go beyond it in order to grow, but you don't have the language or the concepts to do that. And that's why I started studying Jung and esoteric things and astrology, because I felt like I needed some kind of structure that people had developed to talk about these things. That I would just go crazy if I tried to do it on my own.
Wow. Yeah, that's cool. That's an interesting metaphor of the energy crisis, and then, you know, the mind, I guess, and being alive.
And so bumping out those tiles of the artificial ceiling is part of our growth process. And probably everybody in this group has gone through it at some point.
Or also to shrink it down, like the ceiling was to kind of contain it somehow, then so that you could expand. It's like
that's what I felt I had to do at one point. It was just going like just so far out there.
Yeah. So
I needed to make it more grounded.
Yeah. That's a pretty cool metaphor.
So that was for me, the impulse behind that exercise.
Yeah. Wow. That's really
about infinity and, you know, what are we doing here? You know?
And this all has come about now because you were able to unearth some of your files on your computer.
Yes.
Oh God, you must be so happy to be getting this stuff.
It's really healing. It's really, really healing. And I'm really grateful to Bart because he helped me find out how to do it and pay for it.
Wow. That's really remarkable. It's like a lost colony come back.
Right, it is. They're like old friends. I'm trying to show, we're using that camera. I'm trying to show the computer. I have to show the mess all around us. We're rearranging everything. We're really in a mess. But this is the computer. It looks like something out of the Jetsons.
Oh yeah.
These old Macs.
Yeah.
It's a half of a sphere.
Yeah.
And it's weighted, so it really.
But that's how old it all is.
Yeah.
And like I said, some of these go back,
Yeah.
I guess the early 90s or some of the earlier ones. And so I'm glad to dust them off.
Yeah,
And I kind of look at them, it's almost like somebody else wrote it at this point.
Yeah, it's the time machine. It's like the Wayback Machine.
Marjorie, how long were you without all of these files?
Years.
Marjorie,
Yes,
how long were you without all of these files?
for a few years,
Wow.
a few years. I've tried a few times to resurrect them, and life always gets in the way. For the most part, it's been that legal stuff that I just, it just seemed like every time I started to get somewhere, something would go on fire, and I'd have to put it aside to put out another fire. So that's another thing. This is the first time that life has let me pursue this and keep that other stuff on a back burner, so to speak. So there's I see that as some kind of synchronicity happening. And then it seemed like they were all lost for good. After I had saved them, I managed to escape from the house with that computer and the guitar, and very few other possessions.
Wow.
Marjorie,
And I brought it to New York with me, and then I lived in Fairfield for a while. It's been on, was in storage, and I got it back. There's been, and then it just all died, and I was heartbroken.
Yeah.
Yeah, the danger was if you fired it up again, the head would actually crash, and then you'd have the thing really being unreadable. But we found these guys in Atlanta that deal with exactly those sorts of failure modes, and they were able to recover pretty much everything. And they put it all on a thumb drive.
It was on a big external drive.
Well, it's big, physically big, because it's so ancient.
Right. And now it's all on here.
Yeah.
Wow.
But it was like this big, one of those drives.
It was a 5-inch, 8-inch, who knows, Anyway.
Marjorie, a quick question. So is the idea of astrology or tarot cards or similar endeavors a usable thing strictly because of synchronicity, that because of synchronicity, the card that comes up is related to whatever is at hand at the moment?
That is how I see it. That's how people of my mindset see it.
How might others see?
So I think some people have a more magical view of it. I mean, synchronicity is pretty magical, if you think about it deeply enough. And I'm not sure that it's not in some way causal, at this point, synchronicity. That there might be some other operating principle. To my mind, things are unfolding at the same time on different levels. And that these are languages that give you a lens to look into a different level. That's just easier to see than just looking at life. That it breaks it down into a kind of simpler version of things that then allows you to go back to the situation, and you have to kind of slightly cross your eyes and blur them, and you kind of get a sense of what's going on. And it's usually easier to do for somebody else than yourself. And what I'm trained to do, like with the cards, is not to think about it too much, just to see what they say to me and try to just be as spontaneous as I can in saying what I'm thinking. And I've had people come to me who came from a strict Catholic background and they felt like they were sinning to do it. And they hesitated. And I said, well, I feel that the word divination means that this is tapping into the divine. You know, that's really what I believe. I don't want to tell you what to do. And then they've left saying, thank you, because I felt that it was God speaking to me. And that's how I experience it, that it's something larger than myself speaking through me. It's not like channeling, but it's like tapping into a different level of awareness that isn't just my personality.
Well, I see synchronicity as the universe itself, but there's so many levels, real deep levels, that you miss it.
Right.
But still, the whole universe is in union with itself. So it's huge and complex beyond anything you can possibly imagine, but it's still there. That's my idea of synchronicity.
I totally agree. It's working on the unity.
Well, it's unity already. You just
Right.
don't see it all.
Right. And this somehow makes that accessible. It's
The cards.
the cards or these tools somehow help you see that rather than just looking at a crystal ball. Somehow these systems, I see them as systems of, you know, looking at reality. Somehow these systems have a way of opening up the synchronicity to see what might be happening on what we think of as the level of real life, you know, of our everyday life.
What were you alluding to when you spoke about a causal aspect to it?
Causal.
That you thought that synchronicity had a causal nature to it.
I think it may have something to do with our intention.
Intention?
Yeah. And I think on some level, we really are at least co-creators with the divine, which I don't pretend to understand what the divine is. I call it the universe, like with a capital U, is to me, that's my understanding of God.
We're all God, are we not?
Right. And we are also microcosms of that larger transcendent expression of the same thing. And everybody else is too, as that the guy in the video said, everybody's God. And everybody's creating their own universe and their own reality.
But the synchronicity that Steve was talking about, you know, we try to illustrate that with Pauli getting near any sort of experimental laboratory and causing chaos, causing the experimental equipment to fail, to break for no reasons that anyone could find.
It was something in his energy field.
Yeah, he was able to.
He wasn't trying to.
Telekinetic damage to these experiments, so that there was a causal link in that sense, but no one could figure out how he did it.
And I don't think it was conscious on his part
No.
at all. But I think life can work kind of like that.
I can tell you what it was.
Okay.
Monsters of the id.
What?
You're muted, Stephen.
You're muted.
Monsters of the id.
Yes.
Masters of the id. Okay.
Monsters of
Monsters
the
of the id. Okay.
Could certainly be, yeah.
Yeah.
Yeah, and sometimes I think it is unconscious, and it might as well be our demons.
Yeah.
You know, that are causing, quote unquote, causing things. But it's all working together as part of that incredible unity. It's other people's intentions and how it all averages out. And yes, it's all an illusion, but I don't know always what that gets you.
Yeah. I'm sensitive with the time. We're already up to 9:20 plus, so let's call it a night.
We started late.
I know we started late, but we're finishing late, so I'm sensitive about, let's call it night. We'll do another session. It's going to be Marjorie and her colleague Jan talking about
No, it's Jenny.
Jenny talking about their 9/11 experiences.
Oh, wow. That'll be fun.
So,
And she's
Maybe not fun. I shouldn't say fun.
Well, interesting.
Bad word.
you know,
And she's our web designer, by
Yeah.
the way.
Oh, wow.
And this is just like an informal thing that she threw up very quickly, but she does.
Oh,
Yeah.
neat.
She does.
I look forward to it.
So
yeah, no,
we were both in New York. We didn't know each other at the time, but we were both in New York around that time, living there.
Wow.
so
That
Anyway.
looks like a good coming attraction for next week.
Okay.
yeah, that's what it's going to be.
We-
Okay.
Okay.
Good night now.
Good
Night,
night.
night. Have a good.
Good night.
Bye-bye.
Thank you for coming.